or kicking range. Okay, guys, lesson 32, an antiderivative / the indefinite integral. So, we know how to do derivative. And in fact, we're going to practice derivative before we start doing antiderivative. Okay. Let's go through those and then we'll talk a little bit more. So what is the derivative? When it says d dx x squared, what that's saying is take the derivative of x squared. So what is the derivative of x squared? 2x. Because remember, you move the power out front, you subtract 1 from the power, right? Okay. What is the derivative then of x squared plus 42? 2x plus 0. So just 2x. What is the derivative of x squared minus 165? 2x, officially we could say minus 0, but it's still 2x, yes? Okay, so those are all derivatives. What would you guess antiderivative is then? Going backwards. Okay, and so derivative, we know, I think like when we're talking about the powers, we're moving our powers down, right? Antiderivative is going backwards. It's undoing the derivative. Now, so with that in mind, looking at example 1 here. Let f of x equal 2x. Find a function, capital F, that is an antiderivative of f. So what would an antiderivative of 2x be? X squared. Is that the only answer?
I'm going to say no because we wouldn't have asked that.
Okay, well, we just had 3 different problems. And these were all unique problems, yes? But yet they all had the same derivative. Okay, now, so this one was just an x squared. This one was x squared plus a constant. This was x squared minus a constant. So what do those all have in common? They all have a constant. Because even this one that was originally x squared, couldn't that be x squared plus 0 as your original function? So the antiderivative, which they use a capital letter, so f of x equals, it's going to be x squared. However, you can't just write x squared. There are lots of different answers that could work. So to generalize it, we say x squared plus c.
And C would be all the possible.
C stands for constant. So constant. So I'm going to say where C is some number. So technically, there are an unlimited amount of antiderivatives. Because we could go on naming constants all day. Now, one comment I want to mention before we move on and start working with some of this is that based on what we just did, we did all these derivatives, right? They came from 3 different original functions. That when we talk antiderivatives, there are no unique antiderivatives. Okay? When we do derivatives, it's something unique. The derivative of x squared is 2x. You're not going to have anything else that has that same thing here. So, well, I shouldn't say that, but so no unique antiderivatives. Well, because it's x squared plus c. That c could be lots of different things. It's just not one unique answer. Okay, so antiderivative. I generally like to think the opposite of derivative, right? Undoing it. Now, leading in down here. On occasion, you will be asked to find the antiderivative. More often than not, though, you will be asked to find the integral. Okay? Integral, antiderivative, same idea. Okay, it's doing the same thing. It's just the integral has notation to go with it. So, right here, indefinite integration is the process of finding the set of all antiderivatives of a given function. So when you are asked to integrate, you are being told, find the antiderivative. We call this set the indefinite integral, and the following notation is integral notation. So if you see this little, I don't know what I want to call it, this little curlicue thing, right? I don't know, give me a better name for it, I'll go with it, but okay, this is the integral symbol. It's saying to do the integral of 2x dx, you want to do the antiderivative. And what did we already say the antiderivative of 2x is? X squared. And then anytime you do an antiderivative or integral, you always add a plus c. That will be the bane of the existence for some of you because you will continually forget your plus c's. And yes, it will cost you.
Why did you make eye contact with me?
Nope, I didn't make eye contact with just you. I'm just saying that it's an easy thing to forget. Okay, and it will cost you on tests when you forget to put that plus c. So, let's practice a few. And realize here, when you do the integral, anytime they have the integral sign, you'll always see a dx, assuming my exponent is an x. Okay, so this was the integral of 2x dx. So it's the integral with respect to x. Okay, integral of cosine x dx. We're just going with easy ones. We're going with ones that you're supposed to know. So what would be the integral of cosine x dx? Okay. Okay, so I've heard sine x, I've heard negative sine x. I agree, it's one of those. And then I've heard plus c, which we definitely need a plus c. Now, is it sine x or is it negative sine x? Okay, and I'll be honest, this is exactly what I have to do with my cosines and sines, is I have to think about, okay, what's my derivative to work backwards? And so if we just do a side note here, if y is sine x, what's the derivative of sine x? Cosine x, right? So what's that mean? If we're doing the integral of cosine x, it's going to be sine x. Well, I'll do it here in a moment. Okay, so that's kind of my check, is I always go back and think, okay, I know it's some kind of sine x, think forward, and then reverse it. So this is sine x plus c. So you have to be confident in your sine-cosine relationships. It's so easy to mess up. And I say that from experience. Because the derivative, we're doing the antiderivative of cosine, which we know is going to be sine, right? So if I look what it would have been going forward, the derivative of sine would have been cosine. So to go backwards, you're going back to where we came from, and cosine came from sine. Your confusion may be figured out on this next problem. Okay? So now, on this next problem, it's the integral of negative sine t dt. What's the gist of what we all know? Some type of cosine, right? Whether it be positive or negative, we haven't discussed yet. And then, of course, there's going to be a plus c. Now, here's what I would do. We know it's some kind of cosine. Go over to the side for a moment and think. What is the derivative of cosine t? Negative sine t. So, what is the antiderivative or the integral of negative sine t? Positive cosine t. And don't forget, plus c.
So wait, my question is why is the top one not negative sign?
Because when you take the derivative of sine, you get just a regular cosine. So when you undo it, and you take the integral of cosine, you're going back to sine. The negative would come in if you have a sine and you're trying to go back to cosine. Okay, so like if I asked for instead the integral of just sine x dx. If I ask for the integral of sine x dx, well, that is cosine, but that is one that would have to be negative. Because you have to switch that sign around. And we'll talk about that more next time we do antiderivatives. This is just, basic introduction of the idea, but you do have to be careful with the sines, cosines. Did I answer the question?
Yeah.
Okay. Because I think Wade had that same question previously.
Yeah.
Okay. I'm trying here. Okay. Integral of e to the x dx. Yep. E to the x plus c. Because the derivative of e to the x is e to the x. So the antiderivative of e to the x is still e to the x plus c. And, yes, last one. Huh?
It works.
Well, I think what it comes down to is as you go along, and we're doing a derivative here, an antiderivative here, I think what probably happens is it's real easy for the brain to get confused of, wait, which way am I going? Because it's common for me to see, okay, I have to take, we're told to take the derivative there, and then someone accidentally did the antiderivative, or vice versa. So I don't think of the antiderivatives as that bad, just like I don't think of the derivatives as that bad. But again, it's keeping them straight, maybe. I don't know, maybe there'll be some ugly derivatives later on. There'll be ugly antiderivatives later on. So, okay, last example. Let dy dx equal cosine x. Find y. What are they asking me to do? Okay, they're asking you to take the antiderivative again. Okay? It's just a different way of putting it, because think about it. Dy dx is the derivative of what? Dy dx is the derivative of y. So this is y. So we just went backwards. We just did the antiderivative. So this is asking for us to do the antiderivative of cosine x dx. What is the antiderivative of cosine x? And then, as always, plus c. So sine x plus c. Questions? It's kind of like the very first day we introduced derivatives. We're just introducing the basics here. And honestly, I was looking through a little bit ago to check something. Integrals don't come up again until lesson 35. So it'll be next week when we start talking about them more.